So this frame, as you can see here, this is actually a diving platform of a swimming pool. This is the hydrostatic load of the swimming pool, and this is the load of the kids who want to have the jump. Okay, this distance was 6 meters, 6 meters, 6 meters, 6 meters, and that's 3 meters. We need to get, these are the reactions calculated for you. So we need to get the normal bending and shear force diagram. Let's start first with the normal diagram. So, if you want to get the normal force diagram for something like this, when I get the normal force diagram for this thing, I'll do it here. So, first I'll start with what? Let this being a normal, this is the shear, and that's the normal. Okay? Ladies, so in order to get the normal force diagram, so this is the normal force diagram, we said we'll look at everything that's axial. So, if I take a cut anywhere between A and B, what would I look down? What would I see? This 45. So this will be a negative 45 kilonewton. Okay? Right. If I take a cut anywhere between B and C, if I take a cut here, and look there, what will I see? Axial to my member, in the direction parallel to my member. What will I see? But we are doing the normal bending and shear. So I'm using the reactions. Okay? But this is a very nice example, by the way, to understand the difference between an intermediate hinge and a wrist connection. شايفين المنظر ده? This is having 3 members connected. Okay? Right. Again, if I'm doing a cut and looking in the direction axial to BC, and looking there, هشوف حاجة؟ It's a zero. When there's some, by the way, when there is something a zero, you write zero on it like that. Just write zero. Okay? Right. If I'm doing a cut at this cantilever, anywhere in this cantilever, and looking this side, am I seeing anything axial?
Which side?
Anything right of D?
No.
There is nothing axial. So that's برضه zero. الله ده حاجة جميلة ده ظريف. Normal بتاعها حلو. Yes. So if I'm taking a cut anywhere between D and C, I'm seeing what? This thing, which is what? 20 times 3, a compression of 20 times 3, so? So this is a negative 60. Right. If I'm taking a cut under C, here, looking down, anywhere between C and D, looking down, I'll see what? 15. So I'm seeing a negative 15. وبصوا بقى ولا سحر ولا شعوذة. 45 plus 15 is equal to 60. So simply speaking, I had a force of 60. The share of this side was 45. The share of that side was 15. As simple as that. Okay? Right. That's for the normal force diagram. Let's do the reciprocal, the shear force diagram. I'll do it in red. We said the shear force diagram is exactly the reciprocal of the bending moment diagram. Sorry, the normal force diagram. برضو ولا صح ولا شيء. Take a section anywhere between A and B. Look like this. طبعا in an exam you are having this sheet of paper. Rotate it. هنا يعني look there. You are seeing the reaction of 0. That's a big fat 0. This is the shear force diagram. We said this is called what? Link member. Again, by definition, a link member starts with a hinge, ends with a hinge, whether by intermediate hinge, hinge support, whatever is the case. And in the middle there is no load. Classically, the shear force within the link member will be 0. The bending moment within the link member will be 0. They will never have any other thing. Okay? And if you give me any value here, لا مشكلة. For me that's a conceptual issue already. Okay? Let's see what will happen here. ايه الحل؟ Let's take it part by part. So let's look at this side first, right of B. طبعا in terms of zeros, where are the points that I know they are zeros? Zero shear اهي أول حاجة. صح؟ So if I take a section like this and look there, I'll see what. بس خلينا الأسهل حتى. Let's start with BC first. If I take a section anywhere between B and C, and I'm looking left hand side, I'll see what? 45. بصوا بقى. 45 is positive كده. اهي. It's a constant because there is nothing happening here. This is 45 kilonewton. And you notice something? Simply speaking, what's a shear in one member, it will be an axial in another perpendicular member. Okay? Simple as that. تمام؟ Penny. Frames are good or easy to understand, easy to deal with, as long as the members are perfectly perpendicular to each other. And if I don't give you something slanted at a certain angle, whatever, anything other than 90 degrees, if I give you anything other than 90 degrees, you start to get confused. Why? Because it's very clear here. And it's very clear. Okay? طيب. Let's look here. CD. Take a cut. Look up. Is there anything here? This direction? So that's a zero member here. Zero shear. خلي بالكم مين هنا كان زيرو نورمال؟ ده 1 perpendicular. Could you see? يعني so here this برافو. بنت كيشة. Okay? You get what she says now? She just got it from the other perpendicular member to it. It's a 60. Okay? That's the point. So, right. Again. Let's do this member. If I take a section just here, and I look this side, I'll see what 45 plus 15. Is there anything other vertical? No. So that's a 65. What happens to it? It's having a uniform load like that. So it starts, here it must end at a 0, so I'll simply connect it with a straight line. It's a uniform load. For the shear force diagram, it's a straight line. صح? تمام? Okay. So, let's move on. The only one remaining is this guy. If I take a section, I look here, looking this way, taking a cut here, looking down, I'll see what? I'm seeing what? طب اقول لكم على حاجه ثانيه بلاش اللخبطه دي تلخبطكم نعمل حاجه اظرف خلاص just we need C just under C بس خلي بالك when I'm saying just under C I'm looking either doing a cut and look there down here or at everything else okay so the easy way is look down here. So under C I'll see what 180 minus the area of this triangle which is 181. So that's E. That's a zero. That's a zero in terms of shear force diagram. That's a zero. عشان كده هنا this is what? Okay? أهو because of this zero. But is there anything here that will have the طبعا. When I take a cut down here, I'll see a 180 kilonewton. Right? I'll see a 180 kilonewton. Is it positive or negative? ببص كده. it will be negative. على فكرة في الشير قلنا مش فارق كتير موضوع البوزيتيف والنيجاتيف. Okay? So this is negative 180 kilonewton. What's happening here? How does it look? Is it concaving up or down? يعني بقول لكم مش فارقة كتير على فكرة. مش فارقة كتير. You wanna check؟ لسه ما كملناش شغل ايه. This is what will happen here is that here you will see what? You will see some curve here. Okay? Well, there is a curvature. This is a triangle. تمام؟ طيب let's take a cut at its middle. هنا at the height of 3 مثلا. Okay? And look down. Or let's look up easier. Let's look up. Up, everything perpendicular to it هنا. أو خلينا نقول this is including this thing بس هو ده كده كده ده زيرو مش فارقة. So I'll see what this is 30. Okay? And this is 3 meters. So I'll see 30 times 3 over 2, which is what? 15 times 3 is 45. So it's obviously concaving down there. Okay? تمام؟ It's obviously concaving down. Okay? Fine. This is for my shear force diagram. Again, I always like to have the shear force and the bending moment beside each other كده, or under each other, to see them and be able to compare what's happening, understand what's happening. So the bending moment now. Again, this is actually the reason why I'm having this example in specific slope now, because of the bending moment. Because again, as mentioned previously, this case is a very unique case in terms of having the two together beside each other. In one example, that I'm having an intermediate hinge on one side, and here this is a rigid connection connecting 3 members, and that's a rigid connection connecting 2 members. So you'll see different things now. Let's start with what are my zeros? أول حاجة بسم الله الرحمن الرحيم. Zeros. We said we will start with the zeros. What are my zeros? B. What else? The end of the cantilever, not B. The tip of the cantilever. Okay. What else? A. What else? سينا لا بس ده فيلم لوحده سيدي. سيدي هيحصل فيها افلام اكشن. اوكي؟ لا E. E is a hinge support. E. Okay. The whole story بقى is what's happening here. Okay? Fine. Again we said حتى اهو it's very clear. That's a zero. That's a zero. There is nothing in between. أكيد إيه the moment here is zero. Simply اهو take a cut here. Zero times the number is zero. خلاص. So that's a zero. So again we have proven now that bending moment diagram in a bending moment and shear force for link members zeros. Sure. However, for sure it has an axial force. ولا شغلتها تبقى ايه؟ Okay? طيب. Then let's look at the cantilever. Start with the cantilever first. If I take a section here at this part of the cantilever, and I want to calculate this moment, I'll see negative or positive. This is said, صح? So this is negative 20 times 3 times 1.5. صح? So this is negative 90 kilonewton meter. So that's a negative 90 kilonewton meter. Negative 90 kilonewton meter. نازل كده اهو. How did I know it's going like this? Because I didn't have a zero crossing here in the sheet. Okay? So it's not going down. تمام؟ That's a negative number. Try to take a cut anywhere between C and D. Here, 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 here. You will only see what? لا zero here. Take a cut and look up. You are seeing this. You are seeing exactly the same value. It's a zero shear, which means a constant movement. This is the center of the force. And there is an arm of 1.5 meters. صح؟ Okay? خلاص? So I'm seeing the same 20 times 3 times 1.5. Now let's try it. Just take a cut above C. Okay. Just above C. And look up. You'll see exactly 20 times 3 times the centroid, which is 1.5. Okay? مش كده؟ So this is a constant. And it makes a lot of sense. Why is that? Because first you must have a joint equilibrium. This should be equal to that. Second, you're having a zero shear force. And the bending moment is the integral of the shear. So it should be a constant value. Or zero. Zero is a constant. Zero is zero. صح? So it should be a constant number. So here I'm having a constant number. Negative 90 kilonewton meter. طيب. What about BC? As simple as that. I'll take a cut just here. No. And look, what will I see? I see the vertical reaction, which is 45. Wants to smile or sad? Smile, it's positive. So it's 45 times 6. Is there anything else? Okay, 45 times 6 is what? 270. Okay? خلاص? So this is 270 kilonewton meter. And it's a 270, it's a positive 270. I'll simply connect it with a straight line. Why? Because that's a constant shear force here. So it's a straight line. So this is 270 kilonewton meter. Fine. What if I take a cut just beneath C? Down. Here back. What should be the bend? Let's magnify C. So this is with that, this is a 90, just like that. Okay, that's a 270, just like that. So what should I expect? Something opposing them equal to the summation of these two, huh? 360. That's true math. Now this is the check that will save you in this rigid connection. Okay? So I'm taking a section looking down. What will I see? I'll see that what wants to smile is the reaction. The 180 times the 6. صح? What's sad is what? The triangle. What's sad is negative 60 times 6 over 2 times the centroid. But the centroid now is from the vertex, it's not from the base. So what's the centroid? 2 over 3 times 6. Okay? دي بالكم يا جماعة؟ 2/3 of the 6, not 1/3. 1/3 is measured from down. I'm now measuring it from up. Okay? So this is 4. So, somebody do this math for us? It's actually 180. Can? 360. 360 kilonewton meter. And it's possible. Once you like, كأنها ايه, it has a little belly like 360 kilonewton meter. And there is no local maximum because I didn't have any crossings in the shear here. Okay, so this is my case. Concavity? Just simply take a section in the middle and see. مش فاهم. يعني لو بشكل again as simple as that. Okay? خلاص؟ Clear? So now we can see this joint equilibrium. Nice. Yeah, sorry. Minor. Minor. It's opposite. It's positive. Okay? The tail of the arrow is inside. Inside the field. Okay? So can you imagine how this thing would deflect? Deflected shape? Can you imagine how this thing would deflect? Let's imagine it as sketch together. Let's do it in blue. So this thing wants to do like this. صح؟ أكيد يعني. كده. So this again it's maintaining the 90 degrees. مش كده؟ طيب. And this thing wants to do like this, wants to bulge like that. فهنا it's doing like that. As if there is an inflection that will happen here. Okay? And this will want to do like this. Yes, so this thing will be doing like this. Then to maintain the 90 degrees angle. So this is maintaining a 90 degrees angle. Okay? خلي بالك بقى هنا this is this connected to it. There is nothing happening here. There do not rotate with it. It will not rotate with it. Okay? You get the thing?
هو انا بنحطها بس for support يعني.
No. You mean the very reason for this thing يعني? Again, if I'm looking at this thing.
يعني ليه ساعات ممكن نحط rigid connection part؟
Oh, the question is it better or worse? Depends on the case. يعني in a case like this, maybe it would have been better to have this as a rigid connection. ليه? Because this thing, when it transfers moment, you will have a reduction in the value of the bending moment here. Will be shifted. Part of it will go here and part here. So this value will be less. This value, 270, will be shifted كده لفوق. So we'll have a lower positive moment and a little bit of a negative moment here and here. So this will be the case if I'm having a rigid connection. But sometimes it's not easy to construct. يعني if you are asking بقى a little bit of a deep question, what's the difference between here and here in terms of design? Although this is beyond your scope, it's a nice discussion to have. If I'm drawing this thing like that, this is my column and this is my beam. And this part is بنسميها بالعربي رقبة العمود. Okay? And I'm having I'll do it in red بقى the steel bars بصوا like this from the column and steel bars from the beam just embedded to the end of the column وخلاص يعني ممكن بس ينزلوا مسافة صغيرة كده تحت وخلاص مش قضية. Okay? This is the outline بس. طيب what about the rigid connection? The rigid connection another story. This rigid connection مثلا I'm drawing this rigid connection here. بصوا بقى because the cantilever this must be a rigid connection because the cantilever is totally dependent on the adjacent column. And it must transfer the moment to it. It must transfer the moment to the column. So look at what I'll do. When I get the reinforcement, the upper reinforcement that will be here to resist this negative movement, look here, are embedded fully in the column like that. You get the thing? This bar is the one that will transfer that negative movement from the cantilever to the column. طبعا حاجه دي بقى الفيرتيكال بار دي طبعا عادي مش فارقه كتير يعني. وده برضه ماشي كده مش مشكله مش فارق كتير. Okay? However, this guy is the most important one. This one. Okay? هو في الحقيقه it's not from the beam to the column, it's from the column to the beam because the column is constructed first. But after pulling the column, they leave a large portion of the steel bar and then they bend. They bend it. So it's from column to the beam. Okay? طيب حدوته دي بقى ده ظريف دراسه. ده فيلم تاني حلو. So an interesting discussion we're having here. So this guy looks like that. صح؟ مش كده؟ يعني magnify. So خلي بالكوا بقى I'm having this thing that should connect everything to each other. This one it has a positive moment, so it needs to connect like this from here to here. That's the tension side. Okay? وبرضه هيبقى في جزء تاني from here to here. Part of the reinforcement will be connecting this one to this one. Part from here to here. Like that. And this guy will connect, but it has a negative moment, so it wants to do like that. فهيبقى لازم هيبقى في بقى الحديد مكمل كده. Then this is the one that will transfer the negative moment from this portion to that portion. Okay? In addition to the other papers. Okay? يعني دي شكلها بيبقى معقد شوية. تمام؟ طبعا this configuration is necessary in a case like that, or else you should have from the beginning. يعني كان ممكن بقى واحد يعمل مواقع حمام السباحة ده كله. But it would have been a very difficult task to have this as a fixation. And not having this portion خالص. Let's have this as a fixed point. This is not easy to guarantee something like this because the movement will be very weak. The movement will be very weak. شايفين المناظر دي كلها هتطلع. Okay? تمام؟ بس برضه يعني this case I have drawn here is a very extreme case because I'm only drawing the hydrostatic pressure of the water. I didn't draw the lateral earth pressure which is opposite. فيعني in reality there will be something that will oppose this and they will somehow equalize each other. Okay? تمام؟ طيب any questions? Okay, so that's the thing for today. Today we are having a light thing because you're having the exam tomorrow and we had a review session.